All right, in this example, we're going to look at inverse variation. We looked at direct variation before, where y equaled k times x. In inverse variation, if y varies inversely with x, then y equals k divided by x. And remember, k is that constant of variation. So we're going to teach you how to solve for k and write the equation and a few other things in this example coming up. So again, if I go too fast, just pause it so you can copy what you need to copy. I want you to copy everything, okay, including this next question. All right, in this problem, if y varies inversely with x and y equals 20 when x equals 2, then find the following things. The first thing we're going to find is k, the constant of variation. Then we're going to write an equation that represents the relationship between x and y in this problem. Thirdly, we'll find y when x equals 4. And last, we'll find x when y equals 120. So again, if you need to pause it, if I'm going too fast, go right ahead so you can copy these things down. So again, here's our first question. We're going to do the first example here, the first question in it, which is find k, the constant of variation. So we know that y equals 20 when x equals 2. Find k, the constant of variation. In inverse variation, we got y equals k over x. So what do? We substitute the y and x in there and solve for k. So if we put the y number 20 over here in this part of the equation, and the x equals 2 over here, put a 20 and a 2 there, the equation looks like this. 20 equals k divided by 2. So one way to solve this, since k is divided by 2, to get rid of that division, we multiply both sides by 2, something like this. So over here, the multiplication cancels out the division, and we get just k. And on the other side, we have 2 times 20, so k equals 40. Simple enough, just substituting it in, realizing that inverse variation is of this nature here, y equals k divided by x. Now to write an equation that represents this situation, well, again, we start off with our general inverse variation form, y equals k divided by x, and just put in the k number we just found. We know that for this situation, k equals 40. So the equation for this situation is y equals 40 divided by x. There's our equation. That's simple. Substitute the k, just like in direct variation. Just once you find k, put it in the equation. The third part, it says find y when x equals 40. Well, that's simple to do now that we've got the equation for this situation. We know that y equals 40 divided by x, so we just substitute the 4 in for x, so I'm going to put it right here. Whoops, there we go. So now we know y equals 40 divided by 4, which equals 10. So y equals 10 when x is 4. And then the last problem, find x when y equals 120. So we still start the same way with that equation we wrote in step 2. We know that y will equal 40 divided by x. Then we're going to go ahead and substitute the y number in for y. So we're going to replace this y right here with 120 and solve for x. So one way to solve for x, you can think of it as a proportion. We can put this over 1 and cross multiply. So one of the cross products is 120 times x. It will equal the other cross product, which is the 1 times the 40. 1 times 40 is just 40. So now we have an equation here to solve for x. 120x equals 40. So to get x by itself, we're going to divide by 120. You throw that into your calculator and you'll see that reduces to 1/3. X equals 1/3. So when y is 120, x would equal 1/3. So there's all you're going to need to know, Some questions on IXL will say find the constant of variation, K. Well, you saw how that was done. We write the general form of inverse variation and substitute the x and y in there and solve for K. Then if they ask you to write the equation, of course, you just substitute that K number in there. And we get y equals, in place of K divided by x, we put the K number there. Then if you need to solve for x and y, once you have the equation, you substitute that x or y in there, like in 3 or 4, and solve for the missing one. Well, good luck with your problems. Now go ahead to IXL and do the problems I had left for you on your note. Have a good spring break. I'll see you after that.